For the basement wiring, a bid of $1429.0 seems reasonable given the included scope of work. A potential cost breakdown includes materials, estimated between $300 and $400, accounting for receptacles, switches, wires, and related components. Labor is estimated between $500 and $600, based on approximately 10 hours at a rate of $50 to $60 per hour. Demolition is estimated at $150 to $200, calculated from 3 hours at $50 to $60 per hour. Miscellaneous expenses are budgeted at $129, representing 10% of the combined materials and labor costs. The total estimated cost ranges from $1079 to $1279. The bid includes a modest profit margin, aligning with industry rates in Minnesota. For the service change, a bid of $1346.0 is slightly above the average cost for upgrading from a 100 amp to 150 amp service in Minnesota. A potential cost breakdown includes materials, estimated between $600 and $700, encompassing the breaker panel, wires, conduit, and associated hardware. Labor is estimated between $400 and $500, assuming approximately 8 hours at a rate of $50 to $60 per hour. A permit is budgeted at $100 to $150. Miscellaneous expenses are allocated at $124, representing 10% of the combined materials and labor costs. The total estimated cost ranges from $1224 to $1474. The bid incorporates a slightly higher profit margin than is typically observed for service changes. Adjusting the price for greater competitiveness may be beneficial. Consider reducing the labor hours. The initial assessment allocated 3 hours for demolition of old wiring, which might be excessive if the wiring is readily accessible. Negotiating with suppliers can lead to securing better pricing on materials. Also, offer package deals. Consider offering combined pricing for both the basement wiring and service change to attract customers. Market services effectively, ensuring potential customers are aware of the skills and competitive pricing through advertising and networking. When pricing electrical jobs, consider several key factors to ensure profitability and competitiveness. Firstly, accurately estimate material costs. Research and obtain quotes from multiple suppliers to secure the best prices on materials such as wiring, conduit boxes, and fixtures. Consider bulk discounts and factor in potential price fluctuations. Secondly, calculate labor costs precisely. Estimate the number of hours required for each task, including demolition, insulation, and testing. Use prevailing wage rates for electricians in the specific geographic area, typically found through union resources or government labor statistics. Factor in payroll taxes, workers' compensation insurance, and benefits. Thirdly, account for overhead expenses. Allocate a percentage of the business's overhead costs to each job, including rent, utilities, insurance, vehicle expenses, and administrative salaries. A common method is to calculate the total overhead expenses for a period, such as a month or year, and divide it by the total labor hours worked during that period to arrive at an hourly overhead rate. Fourthly, include a profit margin. Determine the desired profit margin for the job, typically expressed as a percentage of the total cost, including materials, labor, and overhead. Profit margins vary depending on factors such as market conditions, competition, and the complexity of the job. Fifthly, obtain necessary permits and licenses. Research local regulations and obtain all required permits and licenses before starting work. Include the cost of permits in the job estimate. Sixthly, consider contingency costs. Set aside a contingency fund to cover unexpected expenses or delays, such as unforeseen site conditions, changes to the scope of work, or material shortages. A common practice is to add 5 to 10% of the total cost as a contingency. Seventhly, offer competitive pricing. Research the pricing of similar electrical jobs in the area to ensure your bid is competitive while still allowing for a reasonable profit. Consider offering discounts or incentives to attract customers. Eighthly, provide detailed proposals. Present customers with clear and comprehensive proposals outlining the scope of work, materials to be used, labor costs, payment terms, and project timeline. A well-written proposal demonstrates professionalism and helps avoid misunderstandings. Ninthly, utilize project management software. Implement project management software to streamline estimating, scheduling, and tracking costs. These tools can help improve efficiency and accuracy in pricing electrical jobs. Tenthly, review and adjust pricing strategies. Regularly review and analyze pricing strategies to identify areas for improvement. Track actual costs versus estimated costs and adjust pricing accordingly. Stay informed about industry trends and changes in material costs and labor rates. When evaluating a bid for electrical work, several components should be analyzed to determine if the bid is reasonable and competitive. Firstly, a detailed scope of work should be identified. The bid should clearly outline the specific tasks to be performed, including the number and type of outlets, switches, light fixtures, and other electrical components to be installed or replaced. It should also specify whether any demolition or removal of existing wiring or fixtures is included. Secondly, the cost of materials should be identified. The bid should provide a breakdown of the materials to be used, including the brand, type, and quantity of wiring, conduit, boxes, fittings, and other electrical supplies. It should also specify whether the materials are new or used, and whether they meet applicable safety standards and codes. Thirdly, the labor cost should be clearly presented. The bid should state the hourly rate or fixed price for labor, as well as the estimated number of hours required to complete each task. It should also specify whether the labor costs include payroll taxes, workers' compensation insurance, and benefits. Fourthly, the overhead expenses should be identified. The bid should include a percentage or dollar amount to cover the contractor's overhead expenses, such as rent, utilities, insurance, vehicle expenses, and administrative salaries. This amount should be reasonable and proportionate to the size and complexity of the job. Fifthly, the profit margin should be identified. The bid should include a percentage or dollar amount to represent a contractor's profit margin. This amount should be competitive with industry standards and reflect the level of risk and expertise involved in the job. Sixthly, the permits and licenses should be specified. The bid should state whether the contractor is responsible for obtaining all required permits and licenses, and whether the cost of these permits is included in the bid. If the homeowner is responsible for obtaining the permits, the bid should clearly state this. Seventhly, the payment terms should be presented. The bid should outline the payment schedule, including the amount of the deposit, the frequency of progress payments, and the final payment upon completion of the work. It should also specify the accepted methods of payment and any late payment fees. Eighthly, the warranty and guarantees should be outlined. The bid should state the length of the warranty period for materials and workmanship, as well as any guarantees or assurances regarding the quality and performance of the work. It should also specify the process for resolving any disputes or complaints. Ninthly, the insurance coverage should be specified. The bid should state the contractor's insurance coverage, including general liability insurance and workers' compensation insurance. It should also provide proof of insurance upon request. Tenthly, the references and credentials should be included. The bid should include references from previous customers, as well as copies of the contractor's licenses, certifications, and affiliations with professional organizations. These credentials demonstrate the contractor's qualifications and experience. When determining whether to accept a bid for electrical work, consider the following factors. Firstly, is the bid clear and comprehensive? Does it provide a detailed scope of work, material list, labor costs, and payment terms? Avoid bids that are vague, incomplete, or contain ambiguous language. Secondly, is the bid competitive? Compare the bid with other bids from qualified contractors in the area. Consider not only the total cost but also the quality of materials, workmanship, and service. Thirdly, is the contractor licensed and insured? Verify that the contractor is licensed to perform electrical work in the jurisdiction and has adequate insurance coverage to protect against liability in case of accidents or damages. Fourthly, does the contractor have a good reputation? Check online reviews and ask for references from previous customers. Look for contractors with a track record of providing quality work and excellent customer service. Fifthly, does the contractor offer a warranty or guarantee? Ensure that the contractor offers a warranty or guarantee on materials and workmanship. This provides assurance that the contractor stands behind their work and will correct any defects or deficiencies. Sixthly, does the contractor communicate effectively? Choose a contractor who is responsive, communicative, and willing to answer questions and address concerns promptly. Effective communication is essential for a successful project. Seventhly, is the contractor willing to negotiate? Be prepared to negotiate the terms of the bid, including the price, payment schedule, and scope of work. A reputable contractor should be willing to work with you to reach a mutually agreeable arrangement. Eighthly, does the contractor have a clear understanding of the project? Ensure that the contractor has a clear understanding of your project requirements and goals. They should be able to offer suggestions and solutions to address any challenges or concerns. Ninthly, trust your instincts. Ultimately, choose a contractor who you feel comfortable working with and who you trust to deliver a quality product. Trust your instincts and don't be afraid to walk away from a bid that doesn't feel right. Tenthly, obtain multiple bids. It's always a good idea to obtain multiple bids from qualified contractors before making a decision. This allows you to compare pricing, services, and qualifications and choose the contractor who best meets your needs and budget. Electrical service upgrades involve increasing the amperage capacity of the electrical system in a building. This is often necessary when the existing service isn't sufficient to meet the electrical demands of the building due to increased appliance usage, renovations, or additions. The process typically includes replacing the existing electrical panel with a new panel with a higher amperage rating, upgrading the service entrance conductors, and installing new overcurrent protection devices. A 100 amp service provides a total of 100 amps at 240 volts, which is equivalent to 24,000 volt amps or 24 kilowatts. A 150 amp service provides 150 amps at 240 volts, which is equivalent to 36,000 volt amps or 36 kilowatts. Upgrading from a 100 amp service to a 150 amp service increases the electrical capacity by 12,000 volt amps or 12 kilowatts. The specific steps involved in an electrical service upgrade may vary depending on local codes, the existing electrical system, and the specific requirements of the building. However, some common steps include firstly planning and preparation. Assess the existing electrical system and determine the required amperage capacity. Obtain necessary permits from the local building department. Coordinate with the utility company to schedule a service interruption. Secondly, disconnecting the existing service that energized the existing electrical service by disconnecting it from the utility company's power supply. Ensure that all circuits are de-energized before proceeding with any work. Thirdly, removing the existing panel. Remove the existing electrical panel and disconnect all branch circuits. Label each wire before disconnecting it to ensure proper reconnection later. Fourthly, upgrading the service entrance conductors. Replace the service entrance conductors with larger gauge wires to accommodate the increased amperage capacity. The size of the wires will depend on the amperage rating of the new service and the distance from the utility company's transformer. Fifthly, installing the new panel. Install the new electrical panel in the same location as the old panel. Connect the service entrance conductors to the main breaker in the new panel. Sixthly, connecting the branch circuits. Reconnect all branch circuits to the new electrical panel. Ensure that each circuit is properly grounded and protected by an appropriate overcurrent protection device, such as a circuit breaker or fuse. Seventhly, installing overcurrent protection devices. Install new circuit breakers or fuses in the new electrical panel to protect each branch circuit. The size of the overcurrent protection device will depend on the amperage rating of the circuit and the size of the wires. Eighthly, grounding and bonding. Ensure that the electrical system is properly grounded and bonded to provide a safe path for fault current. This typically involves connecting a grounding electrode conductor to a ground rod or water pipe and bonding all metal parts of the electrical system together. Ninthly, testing and inspection. Test all circuits to ensure that they are working properly and that there are no faults or shorts. Schedule an inspection with the local building department to verify the installation complies with all applicable codes and regulations. 10thly, energizing the new service. After the inspection is complete and approved, coordinate with the utility company to energize the new electrical service. Verify that all circuits are working properly and that the electrical system is functioning as intended. Common electrical wiring methods for residential construction include firstly, non-metallic sheath cable type NM, also known as Romex. This is the most common wiring method for residential construction. It consists of 2 or more insulated conductors enclosed in a non-metallic sheath. It is suitable for use in dry locations and can be installed in walls, ceilings, and floors. Secondly, metallic sheath cable type AC, also known as BX cable. This wiring method consists of insulated conductors enclosed in a flexible metallic sheath. It is suitable for use in dry locations and can be installed in walls, ceilings, and floors. It provides better protection against physical damage than NM cable. Thirdly, electrical metallic tubing EMT. This is a rigid metal conduit that is used to protect electrical conductors. It is suitable for use in both dry and wet locations and can be installed exposed or concealed. It is commonly used for commercial and industrial applications but can also be used in residential construction. Fourthly, rigid metal conduit RMC. This is a heavy-duty metal conduit that is used to protect electrical conductors. It is suitable for use in both dry and wet locations and can be installed exposed or concealed. It is commonly used for underground installations and for applications where maximum protection against physical damage is required. Fifthly, flexible metal conduit FMC. This is a flexible metal conduit that is used to protect electrical conductors. It is suitable for use in dry locations and can be installed exposed or concealed. It is commonly used for connecting motors and other equipment where flexibility is required. Sixthly, liquid-type flexible metal conduit LFMC. This is a flexible metal conduit that is covered with a liquid-type plastic coating. It is suitable for use in wet locations and can be installed exposed or concealed. It is commonly used for outdoor applications and for connecting equipment that is subject to moisture. Seventhly, armored cable type MC. This is a cable that consists of insulated conductors enclosed in a metallic armor. It is suitable for use in both dry and wet locations and can be installed exposed or concealed. It provides excellent protection against physical damage and is commonly used for commercial and industrial applications. Eighthly, underground feeder off cable. This is a cable that is designed for direct burial in the ground. It consists of insulated conductors enclosed in a waterproof jacket. It is commonly used for underground wiring to outbuildings, such as sheds and garages. Ninthly, service entrance cable C. This is a cable that is used to connect the utility company's power supply to the building's electrical system. It consists of insulated conductors enclosed in a weatherproof jacket. It is typically installed on the exterior of the building and connects to the meter and service panel. Tenthly, knob and tube wiring. This is an obsolete wiring method that was commonly used in older homes. It consists of single insulated conductors supported by ceramic knobs and tubes. It is not considered safe by today's standards and should be replaced with a modern wiring method. There are several types of electrical boxes used in residential wiring, each designed for specific purposes and applications. Firstly, outlet boxes. These are used to mount electrical outlets, switches, and light fixtures to the wall or ceiling. They are typically made of metal or plastic and come in various shapes and sizes. Secondly, junction boxes. These are used to splice or join electrical wires together. They are typically located in concealed areas such as walls or ceilings and must be accessible for inspection and maintenance. Thirdly, switch boxes. These are similar to outlet boxes but are specifically designed to accommodate electrical switches. They typically have mounting holes for attaching the switch and may also have knockouts for running wires. Fourthly, ceiling boxes. These are used to mount light fixtures or ceiling fans to the ceiling. They are typically round or octagonal in shape and are designed to support the weight of the fixture. Fifthly, weatherproof boxes. These are used for outdoor applications where the electrical connections need to be protected from moisture and the elements. They are typically made of weatherproof materials, such as cast aluminum or plastic, and have gaskets to seal out water. Sixthly, floor boxes. These are used to provide electrical outlets or telephone jacks in the floor. They are typically installed in concrete or wood floors and have a hinged cover to protect the connections when not in use. Seventhly, GAN boxes. These are used to mount multiple switches or outlets side by side in a single location. They are typically available in 2, 3, or 4 GAN configurations. Eighthly, extension rings. These are used to extend the depth of an electrical box when it is too shallow to accommodate the wiring and devices. They are typically made of metal or plastic and are attached to the front of the box. Ninthly, handy boxes. These are small, rectangular electrical boxes that are used for various purposes, such as mounting switches, outlets, or small light fixtures. They are typically made of metal and have knockouts for running wires. Tenthly, device boxes. These are electrical boxes that are specifically designed to accommodate electrical devices, such as switches, outlets, or dimmers. They typically have mounting holes for attaching the device and may also have knockouts for running wires. Common electrical tools used in residential wiring include, firstly, wire strippers. These are used to remove the insulation from electrical wires without damaging the conductor. Secondly, pliers. These are used for gripping, bending, and cutting wires. Thirdly, screwdrivers. These are used to tighten or loosen screws. Fourthly, voltage tester. This is used to check for the presence of voltage in an electrical circuit. Fifthly, multimeter. This is used to measure voltage, current, and resistance in an electrical circuit. Sixthly, fish tape. This is used to pull wires through conduit or walls. Seventhly, conduit bender. This is used to bend conduit to the desired shape. Eighthly, cable cutter. This is used to cut electrical cables. Ninthly, hammer. This is used to drive nails or staples. Tenthly, level. This is used to ensure that electrical boxes and fixtures are installed level. Electrical codes and regulations are in place to ensure the safety of electrical installations and to protect people and property from electrical hazards. The National Electrical Code (NEC) is a widely adopted standard for electrical installations in the United States. It provides detailed requirements for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years to reflect changes in technology and industry best practices. Local electrical codes may also be in effect, which may be more stringent than the NEC. It is important to check with the local building department to determine the applicable electrical codes and regulations. Electrical permits are typically required for most electrical work, including new installations, alterations, and repairs. The permit process ensures that the electrical work is performed by a qualified electrician and that it complies with all applicable codes and regulations. Inspections are typically required after the electrical work is completed to verify that it has been installed correctly and safely. Electrical safety is paramount when working with electricity. Always follow these safety precautions to prevent electrical shock and other hazards. Firstly, always de-energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized. Secondly, use insulated tools. Only use tools that are designed for electrical work and that have insulated handles. Thirdly, wear personal protective equipment, PPE. Wear safety glasses, gloves, and other appropriate PPE to protect yourself from electrical hazards. Fourthly, never work in wet conditions. Avoid working on electrical circuits in wet conditions, as water is a good conductor of electricity. Fifthly, be aware of your surroundings. Be aware of your surroundings and avoid contact with any conductive materials, such as metal pipes or appliances. Sixthly, use ground fault circuit interrupters, GFCIs. Use GFCIs in areas where there is a risk of water contact, such as bathrooms, kitchens, and outdoor areas. Seventhly, never overload circuits. Avoid overloading electrical circuits by plugging too many devices into a single outlet or circuit. Eighthly, inspect electrical cords and plugs regularly. Inspect electrical cords and plugs regularly for damage and replace them if necessary. Ninthly, use caution when working near power lines. Use caution when working near power lines and maintain a safe distance to avoid contact. Tenthly, call a qualified electrician for any electrical work that you are not comfortable performing yourself. Always call a qualified electrician for any electrical work that you are not comfortable performing yourself or that requires specialized knowledge or equipment.